Hello, this is Value Added by James Sinclair, the first puzzle in his Artisanal Sudoku Volume 112. It is apparently his very first volume where the first Sudoku is not a killer Sudoku, so there are no killers in this puzzle here. But okay, let's take a look at the rules. Normal Sudoku rules apply, so place the digits 1 to 9 every row, every column, and every 3x3 box. Arrows indicate, well, the sum of digits along an arrow is equal to the digit in the connected circle. So those digits, for example, sum to that digit there, those digits sum to that digit, and so on. Digits in cells separated by a black dot have a ratio 1 to 2, so one digit is double the other. For example, 3 and 6 or 8 and 4, those will work. And I assume not all dots are given, so those two digits can be in a 1 to 2 ratio if they want to be. Alright, so those are the rules. With that, let us just begin solving. I suppose we have to look at the longest arrows first, right? Yeah, because if you place the smallest digits you can in those arrows, those cannot repeat because they're in the same column. They have to be at least 1, 2, and 3. Those have to be at least 1 and 2 for the same reason, and therefore at least these 5 digits will add up to 6 plus 3, which is 9, which is the most you can have. So increasing any of those would make this a 10 and above, which doesn't work. Which means that those digits do in fact have to be the minimum possible. They have to be 1, 2, 3 and 1, 2 here. That digit is therefore a 9, which is the minimum those can be. I'm going to do the same on this opposite side. It's actually just completely rotationally symmetrical, this one. We can also place the 9 in this box because 9 cannot be on the arrow here. That digit's always going to be smaller than 9 because it needs to add with something to make 9. So 9 goes there. Okay. We'll have to work with this one maybe, because it's touching one of the black dots. For example, that digit can't be 1, because a 1 here forces it to be a 2, which breaks this set. If it was a 3, it would need to be next to 6. If it was a 2, it can't be next to 1 for the exact same reason. So therefore it would need to be next to a 4. So there you go, this is either 4 or 6. Oh, I get it, it's those two arrows now actually. Those are pretty conspicuous because they're not part of the main. They're not very long, but because of the 1, 2, 3 triple here, those digits are no longer 1, 2, or 3. They have to be at least 4 and 5, which add up to 9 once again. So this is the minimum we can have, but the maximum here is a 9, which means it has to be exactly 9. Now this 4, 5 pair resolves that. That must be 6, sorry, which must be next to 3. Those digits, for example, 5 can't be here because 5 can't be next to a dot. It doesn't have anything you can go with it. It's either next to 2.5 or 10, both of which are not in the puzzle. And in fact, a black dot only has 4 options. It's either 1, 2, 2, 4, 3, 6, 3, 6, or 4, 8. It's one of those 4 options. And since none of them contain a 5, we know that this digit can't be 5. It must be 4, which is next to 5. Now, this digit must therefore be either a 2 or an 8 to be in a 1 to 2 ratio with 4. But because of the 2 here, this can't be 2. It must just be 8. Those digits form a pair, I think. They have to be 6 and 7. Actually, those digits also form a pair. They have to be 7 and 8. Alright, let's take a look at that digit now. Right, because it can't be an 8, it has to be at most an 8, actually. It can't be 9, sorry. And so what that means is that this digit is at most an 8. Now what does that say about the digits on these arrows? They must contain a 1, and because if they didn't contain a 1, then the minimum we could have them be is 2, 3, and 4, which add up to at least 9, which doesn't work because we know this is less than 9. And therefore, there must in fact be a 1 here, which removes 1 from that cell. That's 2, that's 1. This now can't be 1. So this digit is now, well, it can't be 2, so the minimum we can have this be is 1, 3, and 4, which does add up to 8. So it must in fact be 8 next to 1, 3, and 4. This has to be 4 because it can't be 1 or 3, so that's 4. This is 1 or 3. 4 must be next to 8 because it can't be next to 2. The 2 is already in the box. 4 in this box because of this cell here. Can't be in those cells, so it would be there. The last 2 cells here have to be 5 and 3. Okay. Now I see we know 7 has to be one of those cells because in this row, 7s can't be here, 7s can't be there. So 7's in one of those cells. But 7 cannot be here, because if it was, it would need to be next to 2. That fails as a 1-2 pair already in the row. So 7 can't be there, 7 must be in this arrow, which is accompanied by 2. 2 to make 9. That resolves this 1-2 pair, which in turn resolves this 1-2 pair. The remaining digits in this row have to be 3, 4, and 5. And because of this digit, that digit must accompany it to make 9. It's either 4, 5, or 6. Right, now we need 1 and an 8 in here, correct? And they have to be together to form a sum of 9. But since 8 can't be in that cell, those cells, they must be in here, which must be accompanied by 1. So this is 1, 8. Those digits must therefore be, well, we don't know, they could be 3, 6, or 4, 5. But we know this 1, 8 pair now resolves this. Okay, let's see here. What do I do next? I was a little bit busy. Right, the 1, 8 resolving this. I was a bit busy doing something, so I was called away for a bit, but it's okay. Let's continue. This has to be 3 and 5 to complete the row, and we know 5 can't be next to a dot, so once again this is 3. That's 5. 3 has to be next to 6. That's the only thing that can be there. 3 resolve, well, it doesn't resolve this, but it means this is not 3. This 5 means that it's not 5. Therefore, this can't be 4, otherwise you would need a 5 to make 9. In fact, yeah, this 5 means you could just have removed 5 from there. We can also remove 4 from there, so it's just 6, which must be next to 3. Alright, that probably should not have... Yeah, that was probably really confusing. The point is that because of the 5 here, this must be a 4, and therefore this can't be 4, 5, it must be 3, 6, which has to be in this order. Whoopsies, I'm sorry for confusing. This is now a 5 to finish the box. This is a triple actually. 2, 3, 6, 7, and 5, 6, and 7. With this cell not being a 5. Actually, none of those cells are 5, so 5 must be here. That's also a triple. They have to be 6, 7, and 9. I don't know if I can resolve that. This can't be 9. We do have this final arrow to use, so I guess that is useful. Okay. This 6 resolves this 6, 7 pair. I didn't see that. What else do we have? Maybe this set here. That looks pretty restrictive. Because besides 5, the other numbers that cannot be on next to a dot has to be 7 and 9 because they don't have anything to put next to them. So the 9s here actually remove 9s from those cells. None of the cells besides black circles can be 9s. 9 in this row must be there. Interesting. Alright. So 9 is now in one of those cells, even though we don't know which. We do know, in fact, that that is not 9, though. Oh, so similarly to this 8, we now know that that can't be 9. That is at most an 8, which means 1 has been one of those cells. This digit, therefore, can't be a 1. That digit also can't be a 1. Okay. I can resolve that, though, because there's an X-wing over here. One is in one of those cells and one of those cells. What that is to say is that because these two columns have exactly 2 ones, one for each column, one of those ones are here, one of those ones are here, that makes up all the ones in these two columns. Therefore, nowhere else in this column can there ever be another 1. Therefore, this digit can't be a 1, and 1 must be here. I was going to say, another way to say is that this column must have a 1 in there somewhere, but it's a lot harder to prove that. Well, it's not that hard to prove. You can say 1 is in one of those cells, but because 1 is also in one of those cells, there can only be 1 1 in this box, and they have to therefore be where the intersection is. Which is probably a lot more complicated, that's fair. Okay, so maybe we look at this box now. We'll look at that. Oh, sorry, this 3 actually just resolves this, so I should have done that from the very beginning. That's very much more useful, which prevents us from requiring us to use the X-wing thing here. Anyway, this digit. No, I think it must be 2 or 4. Because it can't be 3, 6, it can't be 1 or 8. It can't be 5, 7 or 9, so it must be 2 or 4. Which must be next to some stuff. 2 cannot be next to 4, and therefore would have to be next to 1. While 4 could be next to 2 or 8. But it can't be next to 8 because of the 8 there. So 4 must be next to 2, sorry. I just had a stroke trying to say that. But okay. 3. I mean, 3 could be in those cells, so we don't know. Yeah. Where else can I find something easy? I don't think I have anything easy right now. Gotta look at some other stuff here. Like, where the 1 and 2 go in this column, they can't be in those cells because 1 and 2 are already in this triple. So 1 and 2 have to be here, which is resolved by that 1. So that's 2, that's 1. Those digits remaining are 4 and 8, which do something. Those digits are therefore 5 and 7 to finish the box. Those digits are 3 and 8, which we can resolve because of this 8 here. Let's keep looking. That digit can't be 8 because that digit we already know is 8 or less. This digit can't be 8 because then this will be more than 8. So that's 4, that's 8. This digit, well, because this is already at least 5, this digit must be at least 2, which means that this digit is now at least 7. And therefore, if this is 7 or 8, this digit must be 2 or 3 to make this a 7 or 8. There's a 3 down there which resolves that, so that's 2, meaning this is a 7. 2 also makes this a 3. 3 in the corner, awesome. 2 means that's 7, so that's 2. This 2 means that's a 4, which must be next to 2, because it can't be next to 1. That resolves this 1, 2 pair, this 4 resolves this 4, 5 pair. And then we have a 7, which can't be in those cells, so 7 must be there. This is a 3 or 6, 3 resolves that, so that's 6, that's 3. Those digits have to be 5, 8, and 9 to finish the box. 8 come in those cells by the boxes below it, so 8 goes there. 5 now can't be here, so that's 9, that's 5, which resolves this 5, 7 pair. And I think we're almost done. 7 come in those cells, so 7 goes here. We got 6, 9 here, nice. Those digits are 3 and 8, I believe. Yes, 8 here means that's 3, that's 8. Those digits are 1 and 6, that must be 6, that's 1, and we're almost done. We just have to do a bunch more pairs to resolve everything. This is 2 and 9, that's resolvable, and we can just resolve the 6, 9 pair in the process. Those digits are 4 and 5, yep. Then those digits are therefore 7 and 6. 6 resolves that. Solving the puzzle in, well, 13 minutes and 51 seconds, even though I did spend a little bit of time doing something else. I will remove that during editing, or I did remove that during editing for you guys. Alright, well, that was cool. I did enjoy this puzzle. I hope you did as well. I will see you guys next time. Bye bye. Hello, this is Dug In by James Sinclair, part of his Artisanal Sudoku Volume 112. This one does have killer cages as opposed to the previous puzzle. So yes, killer cages are back, with also these pink lines which are Renban lines. Alright, let's see. Normal Sudoku rules apply, so place the digits 1 to 9 every row, every column, and every 3x3 box. Killer cages. The sum of the digits inside each cage equal the number in the top left corner. So this cage, for example, sums to 16, the digits in this cage sum to 16, the digits in this cage sum to 13, and so on and so forth for every cage. Now, Renban lines are these purple lines, or pink, whichever you want to call them. I wonder why they're called Renban lines. But anyway, purple lines contain a non-repeating set of consecutive digits in any order. So for example, this line here has 2, 4, 6, 7 digits, and therefore must contain 7 consecutive digits. So for example, something that was a bit like 2, 3, 4, 5, 6, 7, 8. This works because it contains the digits 2 to 8, all consecutive digits, and the order doesn't really matter, so this is fine. Alright, and yeah, those are all the rules. With that, let's just begin solving. Let's start with the killer cages, because I see a bunch we can fill in first. The 1, 3 must only be made of 1 and 2, that's the only way you can make 3 in 2 digits. The 4 must be 1 and 3. The 16 must be 7 and 9. The... is that it? I think that's all the free ones. We do have a couple other ones that are pretty close to having only one option as well. Those all have 2 options. Now I wonder if we can eliminate any of them. Probably not. Although I suppose this Renban line now must have a 1 in it somewhere, because it is 9 digits, right? 2, 4, 6, 8, 9. Yes, and so 9 digits must therefore contain every digit from 1 to 9, because they cannot repeat. Therefore, it must have digit 1 on the line, but because of the 1, 2, and 1, 3 pair here, there can't be a 1 in any of those cells, And because of the 1-3 pair, there can't be a 1 there. So the only place 1 can go on this line is here. Which means now this only has one option. It can't be made of 1 plus 5, it must be made of 2 plus 4. And therefore this one also only has one option left. It can't be made of 1 8, coming of 2 7, or 4 5. It must be 3 and 6. Sweet. Okay. Now what do we do next? I mean, I suppose 3 only has 2 options now in this line. Because of the 1-3 pair here, now those cells can be 3. Because of the 3-6 pair here, none of those cells can be 3. So 3 is in one of those cells in this set. And in fact, we might be able to do something better, because those digits cannot be in those cells because they cannot repeat along a line. They can't be those cells because of the row. Therefore, those digits must be somewhere in there. But they can't be 1. They can't be 1. So they must be whichever digit here is not 1. And because 1 is already in here, those 2 digits are the other 2 digits in these 3 digits. In these 3 cells. I'm sorry if I'm not saying this right. But that does mean that it must contain a 2 somewhere. One of these digits must have a 2 in them. I don't know if that's going to be helpful at any point. But maybe it will be. It must also contain whatever digit this is. This digit is somewhere in here. Can we do the same with this? I mean, sort of, but this digit we know is one of those 3 digits, which is a lot less restricting. Okay. What else can we do? Maybe the 11 cage? Now we have all those digits. Because of the column, it can't be... Well, it can't be 3, 8 or 5, 6, but it... Oh, it can't be 2, 9 because of the 1, 2 pair here. So it has to just be 4, 7, I think. Yeah. Which now means that... Well, where does 7 go? 7 can't be in those cells. Because of the 7 in one of those pairs. Yeah, 7 can't be in those cells. But 7 could still be in one of 3 cells. In fact, because of this... Right, because we know that this digit contains a 2, the other digit will be here. So this must either be 2, 4, or 7. Oh, which forms a triple here, which is very interesting. I don't know if that's going to be helpful at any point. Maybe not. What about the 13 cage up top? I'm just gonna keep inspecting cages. The 13 cage can't be made of 7 and 6, can't be made of 4 and 9, therefore it must be made of 5 and 8. What else do we have? The 8 cage, yes, because of the 1, 3. Can't be 1, 7 or 3, 5, so it must be 2, 6, I believe. It can't be 4 and 4. 2, 6 pair means this isn't a 2, and we know since there must be a 2 on this set, 2 can't be here, 2 must be here. Okay. And therefore this digit is that digit. Right. Now what? I'm wondering if I should still be looking at... You know, I'm wondering if I should still be looking at these cages. The 15, it seems to want to work, but it can't. Like, it still has either 6, 9 or 7, 8 as a choice, and we can't rule them out at all. Although I guess you can remove 7 from here, so you can remove 8 from here. But that still leaves you with 3 options total. Right? Yeah. There's probably more stuff we can do. Yeah, not sure. Okay. Where else can we look? This? Yeah, I don't see it. That's a 5, which is kind of interesting to me. Because 5 is either 1, 4, or 2, 3. This can't be 1, so that can't be 4. I mean, it does form some sort of synergy with this cell, maybe. Not really. Yeah. What is this? This is either 5, 8. No, sorry, 5, 9 or 6, 8. No, I don't think I see this. Alright, well, maybe look at this line then. What could this line be? Well, because there must be 7 consecutive digits. If you look at the number line and you chose any 7 consecutive digits along that line, you'll always hit, you'll always have to, like, if you start from 1, you always hit 7. So if you start from the smallest possible, you always hit 7. If you start from the highest possible, which is 9, and go down, you always hit 3, right? 9, 8, 7, 6, 5, 4, 3, yeah. So you always need the digits 3 to 7 on the line. So 3, 4, 5, 6, 7 are always on the line. Okay, does it help? 3, 4, 5, 6, and 7. I mean, this can't be 3, 4, or 7. I mean, it could be something outside of that range though. So yeah, it's very hard to tell. Maybe this 12, because we have a lot of stuff going on here. This 12 can't be... Oh, that's probably helps us. Yeah, it can't be 5, 7 or 4, 8. So it must be 3, 9. Yeah, alright, that's just it. Okay. Well, now this probably helps us, because now this can't be 5, 9. It has to be 6, 8. Does that do anything? It does restrict... It does restrict... Well, 6 is restricted from those cells. I mean, that's a triple, I think. 1, 4, and 7. That digit can't be 7 because of the 7-9 pair here. This digit can't be 1 because 1's already on the line. So in fact, this is a 4-7 pair. Wow. So those digits form a triple. 5, 8, and 9. So that means that digit now can't be an 8. That's a 6. That's an 8. This digit now can't be 9, so that's 7. That's 9. This 7 doesn't do anything for us. It does remove 7 from here. Oh, no, we already knew that. Sorry. We already removed 7 from that. What else do we have? I can't do the same thing with the 8. 8 can't be in those cells, 8 can't be in those cells. 8 is in one of those cells. Actually, I think so is 9, right? Yeah, 9 can't be in those cells, 9 can't be in those cells. So 9 in this set has to be here. So this forms an 8-9 pair. Which means that that digit is now a 3, because 3 can't be up there, which resolves everything with the 1s. And so now those digits also form a pair. They have to be 5 and 6 to finish your set of 9 along this line. The 5-8 pair resolves that. Oh, this is fun. You're just going around in circles with this line. It has a lot of like cool interactions with this. It has a lot of cool. Sorry, I'm trying to think here. It has a lot of cool interactions with all the cages around it. Alright, this is a triple. 4, 5, and 7. Which we knew. We knew 4, 5, and 7 have to be on the line, so okay. 4, 7 pair means this is a triple. I think this has to be 6, 8, or 9. Yeah. Alright, unfortunately this one is not resolved yet. That's a triple. 4, 6, 7. We do start having a bunch of seemingly repeated digits here. Like, well, this digit syncs with that. This has to be 9, 6, or 7 as well, which forms a quadruple. In fact, the 4, 6, 7 triple here means this can't be 6 or 7, so that's 9, meaning that's 4. So now 6, 7 pair removes 7 from this cell, so 7 has to be here. 4, 5 pair doesn't do anything for us, but we already knew these are all on the line. We also know 3 has to be on the line somewhere, so this 3 resolves that. 3 can't be here, 3 is in one of those cells. Which removes 3 from those cells, which means this can't be a 2, 3 pair now, this has to be 4 and 1. That goes on to eliminate stuff from there. Now we know this can't have a 1 or 2 in it. Wait, but 2 could be here, so... No, it is possible for this to be a 2 to 8, I think. 9 resolves this, so that's 8, meaning that's 9. This now can't be 8 or 9, so that's 6. Meaning that's 9, which must be with 6 to make 15. 7 means this has to be 4, 7. 4 means this has to be 5. That's a pair. I think that's 2 and 5. 5 can't be on its own line, so 5 goes here, 2 goes here. 5 means there must be 1 to be resolved. Those digits are 3 and 8. This digit can't be 3 because that would have to be a 10, which doesn't work. So this is 8. That's 3. 8 means 5 must go up here, which resolves this. Well, 2 is on the line, so now we know it's... We know 1 is not on the line because of that. So we can only start from 2, meaning our line has to be 2, 3, 4, 5, 6, 7, 8. So this must be 3, 8. And actually this 3 resolves that. 8 here, 3 here. This digit now can't be 3, 6, 4, 5 or 1, 8. It must be 2, 7. And I think we're getting close. That's a triple. I think it's 5, 6, 9. 9 can't be in those cells, so 9 has to go in here. That digit now can't be a 9. That digit can be 9 or 8 actually, so that's just 5. 8 goes here, 9 goes here. No, I was saying that resolves this, but it doesn't. Those digits are 1, 5, 7, sorry. 5 can't be there, is that it? I think that's it. Oh, 1 can't be here. In fact, this is also a triple. What are they? 5, 7, 8. 8 can't be in those cells, so 8 goes here. This forms a 5, 7 pair, which resolves both of these. This has to be 2 here. This has to be 6. 6 resolves this 3, 6 pair. Cool. 1, 4 means this is a triple consisting of 1, 4, and 3. This can't be 1 or 4, so that's 3. This is now either a 1 or a 4. In fact, this is a triple with 1, 2, and 4. This has to just be 2. So this forms a 1, 4 pair, which is resolved by this 4. So that's 1, 4, 1. 4 means this is... Well, that's just 7. Which means that it's not 7. It's not 1 either, so that's 5. 7, 5. 7 means that's 1. We're almost done. Just a bunch of triples to go. This is 3, 4, 9. No, not 3, 4, 9. 3, 4, 7. This can't be 4. This can't be 7. This is 2, 8, 9. Yep. This can't be 8. And that's it. 6, 7 pair is resolvable. Cool. Now that's a pair. 3 and... this one's 3 and 6. Which we can't resolve, funny enough. This is 4, 8, 9, I believe. That can't be 4, 8, so that's 9. Which resolves a bunch of stuff. 3, 9, 7... 2. Okay. And this can be 9, so that is probably resolved by this last set over here, which must be 1, which is here. The last digits are 2 and 7, that's resolvable. And this sets off a chain, which should solve everything. 3, 6, 4, 3. 4 means 8. 4 in the last 2 digits. 9, 8. Solving the puzzle in 14 minutes and 17 seconds. I like this one. Yeah, I really like the line over here. Okay. Well, I hope you enjoyed this puzzle. I'll see you guys next time. Bye bye. Hello, this is Crawl Space by James Sinclair, part of his Artisanal Sudoku Volume 112. It is a puzzle with killer cages and copy dots. So that's cool. Alright, so let's go to the rules. Normal Sudokus apply. So place the digits 1 to 9 in every row, every column, and every 3x3 box. Killer cages. The sum of digits inside each cage is equal to the small number in the top left corner. So those digits, for example, sum to 28. Those digits sum to 9. Those digits sum to 6, and so on for every cage here. Digits in cells separated by a white dot are consecutive. So those digits are consecutive, meaning something like 3 and 4, or 4 and 5, or 9 and 8. This all works. Digits separated by a black dot have a 1 to 2 ratio. So those digits are in a 1 to 2 ratio, meaning one digit is double the other. So for example, something like 4 and 8 work, something like 3 and 6, or 2 and 1. Those all work. And now I assume that not all dots are given, so those digits can in fact be consecutive if they wanted to be. Alright, with that, let us begin solving. So yeah, I can definitely see a crawl space here. This is probably why the puzzle is called Crawl Space. So let's start with the cages that look most confined. Actually, yes, the 29s and the 11 cage. There's a lot of 29s here, but those all have only one way to be resolved. Now 29 can only be made of 5, 7, 8, and 9. And the reason why is, yeah, just because there's so many of these cages here, I should prove that to you. If you think about it, what is the maximum you can put in a cage? Because digits in cages may not repeat, the maximum you can put in a cage is 6, 7, 8, and 9. So let's look at that. What does that sum to? That sums to 30. And so how do you make 29 out of that? You have to decrease one of the digits by 1, and you can't do anything else because decreasing any digit by more than that gives you a sum of less than 29, and decreasing multiple digits by 1 gives you a sum of less than 29 as well. So you can only decrease exactly one digit by 1. Now which one should you decrease by 1? Because digits cannot repeat, you can't decrease 7, 8, and 9 by 1 because they will always lead to another digit that is already in the cage. Which means the only digit you can decrease by 1 is 6, which then lends yourself to 5, 7, 8, and 9. So this is the only way to solve, or the only way to fill in the 29 cages. So those are all just 5, 7, 8, and 9. The 11 cage is also similar, wherein the minimum you have is 10, and you want to make 11. Now, to do that, you need to increase one of those digits by 1, and by the same logic, you can only do that to 4, which lends yourself to 1, 2, 3, and 5. So there you go. That's how you do all of this. I do notice we have a 5, 7, 8, 9 quadruple here, and here actually in this column, which may be helpful in the rest of the row here because it does touch more killer cages. So for example, what? Maybe this. Yeah, the 9 cage only has a few options anyway. The 9 cage can't be 4, 5, it can't be 2, 7, it can't be 1, 8. So it just has to be 3, 6. While this 6 can't have a 5 in it, so it has to just be 2 and 4. Meaning those also form a triple, they have to be 1, 3, and 6. And those form a triple, they have to be 1, 2, and 4. Cool. I don't know if I'm missing any digits from this set here that I could place in here. The 13s and 12s are actually pretty constrained as well, because they do have 2 options, but they don't have... They do have 2 options, but yeah. Alright, so yeah, this 28 case is also similar. They also have 2 options. Well, what I can say though... Whoa, my voice just... Well, what I can say though is that all of these cages must have a 1 and 2 in them, I'm pretty sure. Oh no, the 13 cage doesn't need. The 13 cage could have no 2 in them. So yes, the idea is that 28 must have an 8 and 9 in it. And the reason why is because without the 8 and the 9, the maximum you can have is 4, 5, 6, and 7, which add to a total of 22, which is definitely not enough. So it must have 8 and 9 in them. Oh, sorry, it must have 8 and 9, but the way to prove that is to remove one of them at a time. Without the 9, the maximum you can have is 5, 6, 7, and 8, which adds to 26. Without the 8, your maximum is 5, 6, 7, and 9, which adds to 27, which doesn't work. That's too low. So this must have an 8 and 9 in it. The 12 is similar in that it must have a 1 and 2 in it, and you can try to prove that by removing one from the cage and seeing what happens. Remove the 2 from the cage and seeing what happens. The 13s do have to have a 1 in them though, because without 1, the minimum we can have is 2, 3, 4, and 5, which add up to 14. So many cages that require 1 and 2 in them. I feel like that is very bizarre. Like, for example, I don't know how this system would work though. Oh, I see. Where does 1 go in this row? It must be one of those 3 cells, which therefore means that none of those cells can have a 1 in them. That helps, because 1 now in here removes 1 from all of those cells, which puts a 1 in here immediately. The 1 here also does the same, and places a 1 here immediately. Cool. That is really cool. Wow. The 1 here removes 1 from that cell, this 1 here removes 1 from that cell. But those are all very normal. What else can we do? 1 here means 1 is in one of those cells. I don't know if that's useful or not. Same for here. 1's in one of those cells. I think that's a normal. That's just a pretty normal system to have. Yeah. All right. Time to look at what goes on next. I mean, we can also say what cannot be in the 13 cage or the 12 cage, right? Like, I don't think 8 and 9 can be in those cages at all. In fact, the 12 cage can't have a 7 in it either. And that's because if you put an 8 in a 13 cage, the remaining digits must sum to 5, sorry. But the minimum digits you can put in there are 1, 2, and 3, which already sum to 6. So yeah, you can't have an 8 or a 9 in the 13 cage. So none of those digits can be 8 and 9. And those digits can be 8 and 9 because of the quadruple here. So in fact, since none of those digits can be 8 and 9, 8 and 9 must be on the outsides here, which gives us another pair. Yeah, 7 can't be in the 12 cage. I don't know if that's useful or not. We kind of already know by default 7 can't be here because of the quadruple there. So yeah, that's something. Okay, well I do know that digit. We know 8 and 9 can't be there, so 8 and 9 have to be outside, right? But 7 could be here if it was accompanied by 1, 2, and 3. That gives you exactly 13. Does that break? We can't have a 1 in it. Oh no, sorry, it could have a 1 down here. What am I saying? It could have a 1 down there. I don't know what I'm saying. Oh, is it this? No, it can't be, right? We know that now those digits can be 2, 3, or 5. Because both of those digits see all those cells. So this digit can't be, those digits can't be 2, 3, and 5. Meaning if they have a 1 in them, the other digit must be at least a 4. But that gives you only 5. Those digits have to add up to at least 8. Which is easy, you know, because you don't have a lot of restriction on the rest of the digits here. Yeah, so no, I don't think... I feel like it's a good idea, but it's not restrictive enough. Yeah, this 13 cage could have no 2 in it, right? If 1, 3, and 4, 5 do add up to exactly 13. If it had to have a 2 in them, I could say none of those cells can be 2. 2 is one of those cells, which goes on to do a bunch of stuff. But no. Oh, is it those digits? I think it might be. Yeah, because those digits can't be 3 or 6. Alright, let's talk about black dots. Have I talked about it before? I think I did in like the first puzzle. The only options you can have of a black dot are 1, 2, 2, 4, 4, 8, and 3, 6. And therefore, this set here can't be 3 and 6. They therefore have to be part of this interesting set here. Because of the 1 in those cells can't be 1 either. And therefore you only are left with 2, 4, and 4, 8. Those digits therefore have to be 2, 4, and 8, and therefore must contain a 4 in them somewhere. That digit therefore can't be a 4. Does not do a thing to help us. Sort of useful, I guess. It is sort of useful. Is it sort of useful? Maybe. I want to do more with this. I don't know if I can though. This is 1, 2, 3, 4, and 6. Oh, that is something. Those digits are relatively low. It's like, because 7 can't be here, one of those digits have to be a 7, right? And if 7 is in a cage with a 13 in it, it must be 13 with 1, 2, and 3. And it can't be in this cage. There you go. Because if it was here, then those digits have to be 1, 2, or 3. But we know it. Besides the 1, it must have another digit. The other digit would have to be 2 or 3 if 7 was in this cage. But it doesn't work because we know 2 and 3 do not appear in one of those cells. Oh, that's amazing. So in fact, 7 in this box has to be one of those cells, which gives us a 1, 2, 3, and 7 in here. In fact, 7 is in one of those cells. Ah, that's cool. Which means that now 7 can't be in those cells. Which means 7 is not one of those cells, which means 7 is not in one of those cells. Ooh, that is clean. Okay, that has to help us somehow. I mean, it is a 589 triple here, followed by a very random looking sextuplet, whatever. Oh, right, because we know this is 1237, we know this can't have a 2 in it because it would see that, so 2 can't be here. There you go. So 2 must be here, which means that this digit now can't be 2. That's 4. That's 4, that's 1. Okay. We're somewhat getting there. This now can't be 1, so 1's up here, which moves 1 here, which moves 1 here. Okay. So now we just have this set to open up. Okay. This, because of the 2 here, this must be 1, 3, 4, and 6, right? Yes. What are we missing from this box then? 5. I'm missing a 5. 5 has to be one of those cells, because 5 can't be here. Which now means 5 can't be in those cells, which means 5 is in one of those cells, which means it's not in one of those cells. Which we could have also done by this triple here. 5 is in one of those cells by this triple. Anyway, with the 5 here, the remaining digits must add to 8. 5, 1 actually adds to 6, so the remaining digits must add to 7 after that. So 2 digits add to 7 without using a 1, 6 or a 2, 5 has to therefore be 3, 4. This has to be 1, 3, 4, and 5. This digit now can't be 2 or 5 because of 3 or 5 because of this set here. So we now know it's 1 or 4. Ooh, that's clean. This 3, 5 means those digits form a triple. They have to be... Well, firstly, let's start with this here, resolving that. Those digits are now 1, 4, 6, I believe. Yeah, 1, 4, and 6. Which hopefully does something. Maybe it does something. Okay. Yeah, I really like this puzzle so far. This puzzle is, I want to say adorable, but no, it's really big brain. I use this cage so many times. We use this idea so many times. Okay, now what? I don't know. What do we do now? I mean, this forms a quadruple here. We still need a 2, 3, 4, 6 somewhere. I don't think I should pencil mark this. Fours are one of those cells. Can we prove what's in this 28 cage? I mean, with the 17 here, the remaining digits have to add to 9, right? Well, they can't be 1, 8. They could still be 3, 6. Yeah, they could if those were 3 and 6. They could still be 4, 5. They could still be 2, 7. Oh, well, that's 4, 4 is one of those cells. So in fact, 4 in this box is one of those cells. That's not very restricting because it's not fully in a cage. I would have preferred it if it was fully in a cage. I also realized I've not used the dots so far. Is this the same? Yes, it is the same as the 1, 3 here. Because the 1, 3 here, this can't be 1, 2, it can't be 3, 6. It has to either be 2, 4 or 4, 8, which must contain a 4 in it somehow. Which means 4 in this box is now one of those cells. If I look at this 13, is this a 12 or is this a 13? I can't read. It's a 12, okay. So 1, 2, and 4 here would mean a 5 is in here. And in fact, because of the 1, 2 here, the remaining digits have to add to 9. They have to either be 3, 6 or 4, 5. But it can't be 3, 6 because there's a 3 in one of those cells which sees all of those cells, so it can't have a 3 in it. Therefore, it has to be 1, 2, 4, 5. And because 4 is in one of those cells can't be 4. 4 must be here. Which means that is not 4, 4 is now here. Ooh. 2, 5 means this is not now a 2, 4, it is a 4, 8. Those are a triple, they have to be... Sorry, 6, 7, 9. which means 4, 8 here removes 8 from those cells. 8 is one of those cells, which looks at all those cells, but we don't know about that. Is this a triple? This is a triple. Whoopsies. I think it has to be 1. No, sorry. How am I saying 1? 2, 3, and 6. That digit now can't be a 2. Actually, 1, 3 here means this can't be 3. So it's just 6. In fact, 3 here means it can't be 3. That's just 2. That's 3. This 2 means that is 8. So 8 is now not in one of those cells. 8 is one of those cells, which removes 8 from one of those cells. 8? It removes 8 from both of those cells, sorry. I could probably do more, but I don't know if we can. Oh, sorry, this 2 resolves that. I don't know why I didn't see that. So this is a pair. They have to be 9 and 7. Which is good because this now can't be 9. It will have to be next to 8 to be consecutive, but 8 is already in the box. So this is 7. This is 9. 7 now can't be next to 8 again because it's in the box, so it must be next to 6. That puts a 6 down here. 7, 9 means this digit can't be 7 or 9. So 5, 8 means this must be 7, 9. This is a single 3. Well, that is a pair consisting of 2 and 5. 7 resolves this. Well, it's not resolving, but we can put a 7 in this box now. 9 means that's 5. There you go. So in fact, this 9 means 9 is not there. Whoa. Right. Now what? This solves a 2, 3, 4, 5 quadruple, I think. Yeah. I mean, there's probably still something here that I'm not seeing. 6, remove 6 from that cell. So 1, 4. Oh no, what about this? Ah, there you go. This can't be... It has to just be 3, 6, I think. Because of the 1 in that cage, it can't be 1, 2. It can't be 2, 4 because it's 4. It can't be 4, 8. So yeah, it has to be 3, 6. Which means that this 6 resolves that. 3, 6. This 3 means now 3 is not there, so 3 goes here. This resolves that, so now that's 7. 3 actually resolves this, so that's 1. So that gives us the entire cage here. 1 means that now it's now be 6. 7 resolves this pair, which resolves this thing up here. And I think we get a lot of stuff for free actually. This can't be 6, so that's 1. That's 6. 1 resolves this 1, 4 pair, which resolves this 4, 8 pair. 3, 5 actually is just resolved. I think it was there a while ago. Yeah, I think it was from this 5. I think that's a triple which contains 1, 7, and 8. 7, no, not 1, 7, 8. 7, 8, and 9. Sorry, this can't be 7 or 8. That's just 9. The column. This is now 7 or 8. 9 now can't be there, so 9 is up there. This is a triple. It have to be 2, 5, and 7. Can this be a 2? Maybe not. Yeah, because a 2 would give you 26, right? And you can't put 26 in 3 digits. The maximum you can have in 3 digits are 7, 8, and 9, which is 24 only. So this can't be 2. So this is either 5 or 7. I think both work. Yeah. Okay. More Sudoku. Let's see. Is this a triple? Yeah, this is 2, 4, or 5. 6 in one of those cells. Four in this box? Yeah, 4 in this box by Sudoku is just here. Which means now 4 is in one of those cells. Can 4 be here? Yeah, 4, 7, 8, 9 does add to 28. Oh, this is another quadruple, so this forms a pair. This is a 3-6 pair, which we can resolve by this 3 here. That was a little weird. Actually, this 3 resolved that. I don't know why I didn't see that. We need a 2, but 2 has to be here, right? Because 2 can't be beside the dot. Because, you know, 3 and 1 are all used up, so 2 can't be on the dot. So 2 is here. This is now 4, 5. Actually, now 5 can't be here either, because 5 can't take 4 or 6 on the dot. So 5 has to be here in this box. So now this is 7, 8, or 9. This 9 means that is not 9. There must be an 8 in here, right? This is either 7, 8, or 8, 9. So 8 can't be there. Which might mean... Oh, this 8 actually just removes 8 from those cells, so I think we should have done that instead. This resolves that, which continues somewhere. I don't see where though. Sorry, I thought I saw something. Yep, 7, 8 pair. That's a 5. Which means those digits have to sum to 28 minus 14 is 14, but without using a 5, 9, it has to just be 6 and 8. Which we can resolve. Wow. So now that gives us all of that. 7 must be next to 8, can't be next to 9. Which resolves all of this. 5 here resolves this. 2, 5. 2 means that's a 7. 5 actually makes this a 4, which gives us this over here. 8 gives us a 9 over here, and I think we're basically done. Just regular Sudoku to go. That is a 2, and the last 3 digits are 3, 5, and 9. That digit is a 5, that digit is a 3, and that is a 9, solving the puzzle in 22 minutes and 14 seconds. Cool. Yeah, I really like this trick. I don't know why, it's just so much fun. Alright, well, I hope you enjoyed this video. I definitely enjoyed the puzzle. I'll see you guys next time. Bye bye.